So far, we have seen a static page communication process in Rails, and we also created our application static. And in the static request response cycle, we have seen some process going on, and we have not yet seen about any dynamic content, any dynamic life cycle, or any dynamic request response cycle, and we have not yet used model. So before getting into and dive deep about the model, we first look about the Rails core software engineering design pattern, which is an MVC. So model view controller, MVC, uh, is a design pattern which is, so for an example, I'm going to tell that this is your video games, and here's your PlayStation and your joystick and your television. Just think about it like the PlayStation, which is your video game, as your model, and the joystick as your controller, and the TV as a view. Yes, of course, the what happening inside in the game PlayStation is you load the game in the model, which means you are loading some data inside the model, and the loaded game is visualized in the view, and you're controlling the loaded game and the visual in the TV using the controller, which is a joystick. This is pretty simple. If you are not aware about MVC, or if you're confused about MVC, or if you're struggling on MVC, this is the basic thing and basic example that you should remember. And yes, of course, this is the concept that we also going to use in our web application too. So we'll see the Rails communication process too, which is the request response cycle with uh, model, which means a dynamic content. So now let's talk about the dynamic content in our Rails communication process. When a user opens his browser and types the URL in his browser, after he types the URL and press enter, the URL request hit the Rails router, which is inside the config folder and inside the rail router.route.rb file. And after that, the request hits the Rails router. The router maps the URL to the correct controller and action to handle the request. And the action receives the request and asks for the model for is there any fetching of data or manipulation of data over there, and if it is so means it will check in the database. If it is so means it will fetch the data from the database, and then it will retrieve the bunch of data to the controller, and the model returns the controller action passes the data to the view, and the view renders the page as HTML and return back to the controller, and the controller gives the HTML page in your browser, and the user can view the application. So the first process is, once for the recap, the first process is user hits the URL and request in the browser, and second it will goes down to the Rails router, and the router request for the controller, and controller asks to the model if there any fetching or data manipulation over there, and if it is so means it will retrieve the fetched data to the controller, receives back the fetched data to the controller, and the controller will sends the information, which means the data, to the view, and view renders the page as HTML and return back to the browser, and the application is viewed by the user. So this is the Rails dynamic communication process. In this process, we used all the three concepts of MVC. MVC, which means which is used basically to code organization, neatly organized code by a developer. So the model code typically reflects the real world things like the Facebook statuses, Twitter statuses, and Twitter tweets, and YouTube videos like that real world things. And in the model, the code can hold raw data or it will define the essential components of your app. For instance, if you're building a blog application, the model code would define what post title is, and also it should define what post description, which means the body content of the post. So this the data which is handled by the database, those stuffs and all taken care by the model. And the view. A view is made up of all the functions that directly interact with the user, and this is the code that makes your app look nice and otherwise defines how your user sees and interacts with it. And then next thing is controller. Controller code acts ambassador between the view and also the model, receiving the user inputs and deciding what to do with it, and what is the process, and is there any condition applied from the model, or is there any restrictions to view some data. Those kind of stuffs and all handled by the controller. Basically, controller is the brain of this process. So when it comes to model, we should also take a look at the powerful pattern used in Rails, which is the active record pattern. Active records is basically which in turn deals with the objects and its behavior. The active records takes the opinion that ensuring data access as the business logic and the data, and it is actually derived and described through the ORM, which is the object relational mapping. The active records gives several mechanisms in Rails framework, and it represents the models and the data, and also it represents the association between these models, and it represents the inheritance hierarchies through the related models, and also it will validate models before they get persisted to the database. And finally, and very importantly, it performs database operations in object-oriented fashion. It is the most stylish thing in Ruby on Rails. Active records take care of everything upon the database. So, for example, if a user wants to store data in the database, he can store easily. That is taken care by active records. If he wants to retrieve the data from the database, it will retrieve easily. They're also taken care by active record. So if there is a bunch of huge data warehouse, and in some other relational databases or in some other patterns, there might get an managing of records, indexing the records and fields, and but in active records, all of the steps, all of the heavy lifts are taken care by the active records. So it is the one of the major advantage in Ruby on Rails. An active record also plays a major role in COC, which is convention or configurations. For example, when writing applications using other programming languages or framework, it may be necessary to write a lot of configuration code. This is particularly true for ORM frameworks in general. However, if you follow the conventions adopted by the Rails, you'll need to write very little configurations, in some cases no configurations at all, when creating your active records models. This means, the convention over configuration means, I'll give you the simple example. If you are using a SQLite database as a default, and you're working in a company, and if your boss says to change your database from SQLite to MySQL or PostgreSQL in other programming languages or in other scripting languages like PHP and Java and whatever, you need to do a bunch of configurations. You need to change the entire model, the entire setup, entire network setup in the configuration, entire setup in the project. But in Rails, you just need to change the single line or a single word from what the database from SQLite to MySQL, and then active records take care of all the bunch of stuffs in the MySQL or PostgreSQL, whatever database you want. You need not to do any other configurations. You just need to concentrate on the code only. And there is also naming conventions in active records. For example, if you're creating a model, it should specify in a singular, and if you're creating a table, it will specify as articles, which is plural. Binary data types are used to store images, audios, videos, and some binary content files. So if you want to store a bunch of assets like files, if you want to upload an image, or if you want to upload an audio, or if you want to upload a video, you may use the binary type. And next, the Boolean. It is basically used to store true or false values, and then integers are used to store whole numbers, and then float is used to store the decimal numbers up to the precision of 16. And in MySQL, it is specifically for MySQL, it can store up to the precision of 16. And decimals used to store exact numerical precisions like p and scale of p. These are all comes into the part of MySQL. You can set the precision and scale in the MySQL query, but according to the Ruby on Rails, you just remember it is the decimal is used to store a decimal value of a number. And then date. Yes, of course, date is used to store a date, and time is used to store a time, and date time is used to store both date and time in a single column, and timestamp is also used to store date and time in a single column. So, but what the difference between the date time and timestamp? So basically, date stores a date, time stores the time of a day, and while date time stores both the date and time. The difference between the date time and timestamp is a bit more suitable. Date time's a bit more similar. Date time is formatted as year, month, and days, date, and also with hours, minutes, and seconds. It will be in the format of years, month, date, and hours, minutes, seconds. But in timestamp, it will vary. In daytime, it has a valid range, grows from the years, like 1,000 years to the 9999 years, and everything in between the 1,000th year to 9,900 years, we can store any years, date, time we want. But in timestamp, it looks similar when you fetch it from the database. It is really just a front for Unix timestamp. Unix timestamp is nothing but to describe an instance of a time from the UTC, which is a coordinated universal time. If you want to know more about that, you can check out in your description file. And its valid range, timestamp valid range, goes from 1970 to 2038. The difference here, aside the various built-in functions within the database engines, is storage space and built-in functions. Because daytime stores every digit in a year, month, hour, minute, second format. It uses up to a total of 8 bytes. As timestamp only stores the number of seconds since 1970, 1970, it uses 4 bytes. So this is the difference. It will store the date as in the format of hour, month, hour, year, month, hour, like that, and it will store the number of seconds since 1970 to whatever date that you specify. It uses just a 4 bytes and daytime uses 8 bytes. So, and the primary key. Primary key basically used to So next is primary key. Primary key is basically used to store a unique ID in a column. So for example, primary keys have some constraints. It should not store a value in a column with null. It should, which means the not null constraint, and also it should be in unique ID. It will be unique, and also it should be indexed properly. Strings. Strings are used to store a sequence of characters. And next is text. Text is used to store longer text, which means strings has the limit of about 255 characters as default, but in text it has a limit of about more than 4 billion words, 4 billion characters as a default. So text is used to store a longer text, longer words, like to fill the descriptions, body, and some posts. For the longer content, you use text type, and if you want to store the just heading or title, you can use the string. So now I created an application name as Blogger, and you also create an application, new application. So and then I'm going to create a model using the command Rails generate model post, and I created so, and then I'm going to specify the type, which means the column, which is a title of string and body of text. And after I written the command, it generated 2 files, one inside the db/migrate and created post.rb, and inside the models it also created post.rb. So let's check it out. Inside the app, models, and post.rb is created a model called post, and it will inherit from the, and it is inherited from the superclass, which is a base class of active record, and active records do the heavy lifting stuffs for like fetching the data from the database and manipulations of data. And if you're coming from a different technology like PHP or Java, J2W, you need to do that. You need to do these stuffs and all very manually. You need to write some queries, and you need to write some codes to, not some, you need a bunch of codes to write in other technologies. But in Ruby on Rails, all the heavy lifting stuffs are taken care by the active records. You don't need to worry about that. It's awesome, pretty awesome. So, and then inside the db migrate / create post method, it also created create post, and inside of that the change method is there. So basically the change method tells Rails to what changes need to be happen inside the database. And then a create table method, the change is it needs to create a table to the database, which is named as a post table to the database, and with 2 columns and with 3 columns, and with a column name as title and a body which type is string and text, and also the timestamp column basically used for the date and time. And it also adds 2 more columns, which is created at and updated at those stuffs, and it will do that. So it created a table. Inside the table that is having a column named as string title and a body, and also the timestamp columns such as created at and updated at. Created at and updated at column says that if you created a post, it will shows what the time the post is created, and if you update or edit in your post, it will also specify the current time that you have updated. So, and then we are going to migrate the database using the command rakedb :migrate. And the rakedb migrate command updates the database with new messages in the data model. And finally, we are going to seed the database. Seed method basically just a command used to seed the database with sample data in the db.seeds, and rakedb. Just look at here at the seeds data, and inside when I do the rakedb seed, it will seed this with a sample data. And after the migration, it will create a schema, which is a snapshot of how our table looks like. Our table has a 4 column, which is a title and a body, created at and updated at. So far we have created a model, and next we are going to create a controller. So to create a controller, I'm going to use the command rails generate controller as post and index. And it created a post controller RB, and also it will set a route for post/index. Basically, after we created a controller, it will we all know that it will just create a controller on controller post controller.rb like that. And this index, what's this index? And if we did not specify an index here, we need to specify the route manually, like we did in the previous video. But if we specify index here, it will automatically generate and set the route to the index action. So that's it. When we get into the post controller.rb, inside the post controller.rb, it is action. Basically, we all know that method inside a controller is known as an action. It will automatically generate an index action while we type index over here when we generate a controller, and then it also set the route inside the route config routes.ob. Here it is. It will post the index, post/index. Inside the post controller, it will have the index action. So that's pretty awesome. And next thing it is created, it also created some test files, and in the view it also created the index.html.rb. let's check it out. Post index.html.rb, and I'm going to edit this as my dynamic Ruby on Rails application. It is gonna work beautifully. I'm going to save this, and I'm going to click run button. If you're using the Ruby on Rails locally, you need to type the command as Rails server or shortcut as Rails yes. So the inside of this is the default page. When I type the index, it shows an error. Oops. We set the route in the routes.rb as post and index. Inside of the post controller, we just specified the action. I did it wrong. So inside the post and then type index, we'll get this message in the index.html file. So this is it, my dynamic Ruby on Rails application. It's gonna work beautifully. Then that's it. We have just created our first model view controller dynamic application in Ruby, and in the next video we are going to create a simple blog application which has title and post and CRUD stuff, which is a create, read, update and delete stuff inside the application.